All right, let's step into the lab. Today, we're going to demystify one of the most useful, powerful, and honestly essential techniques in all of chemistry, liquid-liquid extraction. Think of it as the ultimate cleanup crew for your chemical reactions.
So, imagine this. You've spent hours, maybe even days, running a reaction. And you know deep in that flask is the prize, the molecule you worked so hard to make. But it's just swimming around in this messy chemical soup of leftovers, byproducts, and salts. So the big question is, how in the world do you get it out?
Well, the answer to that chemical soup problem is a really elegant technique called extraction. The whole game is basically convincing your target molecule to pack its bags, leave that messy mixture behind, and move into a nice, clean new home.
So what is it really? At its core, liquid-liquid extraction is all about separation. It works by taking advantage of how different chemicals dissolve in two liquids that, just like oil and water, absolutely will not mix. We call these immiscible liquids.
The science behind this is actually really cool, and thankfully, pretty simple. A chemical is always going to try to find its happy place. So when you give it two liquid options, it will naturally move into the one where it dissolves better, where it's more soluble. And the bigger the difference in that solubility, the cleaner your separation is going to be.
And just so we're all on the same page, there are really two main kinds of extraction. There's solid liquid, which is what happens when you brew coffee or tea. You're pulling compounds out of a solid. But today, we are laser-focused on liquid-liquid extraction. This is the absolute workhorse for cleaning up reaction mixtures in the lab. Okay, so that's the theory. But how does this actually work in practice? Let's get our hands dirty, so to speak, and talk about the classic shakeout method. Meet the star of the show, the separatory funnel. Or as chemists call it, the SEP funnel. It's a simple but totally brilliant piece of glass. And its most important feature is this little tap at the bottom. That's called a stopcock. It gives you perfect control when it's time to drain the layers. Now, to get your molecule to actually switch sides, you can't just let the liquid sit there. You've got to shake it. And the best advice I've ever heard is to shake it like a bartender mixing a cocktail. That vigorous shaking creates a massive amount of surface area between the two liquids, which lets your molecule jump from one to the other super fast.
Let's break it down into 4 key steps. Step 1, fill it up. But first, and this is crucial, make absolutely sure that stopcock is closed. Step 2, shake and vent. You pop the stopper in, flip it upside down, and give it a good shake for about 20 seconds. Now, it's super important to point it away from everyone and open the stopcock to release the pressure. You'll hear a hiss. You just repeat that until it stops hissing. Step 3, let it separate. Put it back in a ring stand, take the stopper off, and just be patient. Let those two layers form a nice crisp line. And finally, step 4, drain and collect. You carefully drain the bottom layer out of the bottom, and then, this is a pro move, you pour the top layer out through the top opening. That way, you don't get it contaminated by any drops of the bottom layer left in the stem.
Okay, so you've done one shake, you've separated the layers, you're done, right? Not so fast. See, one pass is almost never enough, and our nice, clean, organic layer is still hiding a little bit of pesky water. It's time for the finishing touches. In chemistry, 3 is kind of the magic number for extractions. You'll almost always repeat the process a total of 3 times, using fresh solvent each time. So why? Well, remember that equilibrium thing? A tiny bit of your product always gets left behind. By doing it 3 times, you ensure the amount left in that original messy mixture is practically zero. You get almost everything out. So after you've done your 3 extractions and you've combined all the good organic layers together, there's one final enemy to take care of: water. Even though the liquids don't mix well, a little bit of water always dissolves in your organic solvent, and we need to get rid of it.
We do this with a little 1-2 punch. First up is a pre-dry. You wash your organic layer with brine, which is really just super salty water. The salt makes the water in your solvent want to jump into the brine layer. Then, for the final knockout, you add a solid drying agent, something like sodium sulfate. This stuff is like a sponge. It literally soaks up the last few traces of water. A quick filter to remove the solid, and boom! You've got a clean, dry solution of your pure product.
Now, like any lab technique, extraction can have its little quirks and problems. But don't worry, I've got a few pro tips that will help you troubleshoot like a seasoned chemist and avoid some of the most common mistakes.
Okay, this is probably the #1 question everyone has. Which layer is which? Where's my stuff? It all comes down to one simple thing: density. Most of the common organic solvents you'll use, like ether or ethyl acetate, are lighter than water, so they'll float on top. But
And you have to be careful here. Some solvents like methylene chloride or chloroform are heavier than water, so they'll sink to the bottom. The lesson? Always know the density of your solvent.
Ready for a little rapid-fire checklist? First, always have a beaker under your funnel. Leaks happen. Second, don't fill the funnel more than about 3/4 full. You need that empty space to get a good mix. Third, if you're ever just not sure which layer is which, here's a great little trick. Add a few drops of water and just watch which layer it joins. And finally, if you get that annoying cloudy layer in the middle called an emulsion, try adding a little more solvent or some salt. That can often help break it up.
And now for the single most important rule of extraction, the golden rule. If you remember nothing else, remember this. Never, and I mean ever, throw away a layer until you are 100% absolutely positively certain you have your final product. It is the easiest and most painful mistake you can make. Just keep all your flasks until the very end. So there you have it. It's a journey, right? We've gone from that chaotic, messy chemical soup all the way to a purified, clean substance. Liquid-liquid extraction is truly an elegant and absolutely essential tool. It's the skill that brings order to the chaos of a reaction, paving the way for the next step in discovery. And it really makes you think, doesn't it? This isn't just some abstract thing chemists do in a lab. It's fundamental to creating life-saving medicines, to isolating the flavors that make our food delicious, and so much more. The next time you take a pill, or even just enjoy your morning cup of coffee, take a second to appreciate the beautiful, powerful chemistry of extraction that probably made it possible. Thanks for tuning in.